Hello, my name's Luke Shutler from the IBM Systems and Technology Group. I'm often questioned by customers, how do we make our products different from our competitors? Because after all, we use the same components. We use the same hard drives, we use the same processors, we use the same memory. So it's a very valid question. Hopefully today, I'm going to show you exactly how we can be different in this marketplace, exactly how we can be so creative that we can drastically reduce the costs for our customers. I'm going to hand you over now to the technical team who are going to explain this technology in more depth and show you exactly how it works.
Hi, my name's John Patterson and I work in the System X Technical Specialist team here in London.
Hi, I'm Sonny Pond. I work from the same team.
So Luke spoke earlier about the investment that IBM has in the x86 space, and I'm just going to focus in on one particular technology called Max5. But before we talk about Max5, I think it's important that we understand the benefit of Nehalem architecture that's been brought in with the Xeon 7500 range. So the key thing that Intel have done with this generation is move the memory controller off the motherboard and into the CPU. So previous systems, let's say it's a 2 CPU system, and then those 2 CPUs may have 4 cores, would have a memory controller which sits separate to the CPU on the motherboard. Data would flow from memory beneath the memory controller on the DIMM slots, up through this one memory controller, out through a front-side bus, into the CPU cores. Now, when Intel introduced Nehalem EP and now Nehalem EX, they get big bandwidth increases between memory and CPU by integrating the memory controller onto the chip. So if we drew a similar system today with Nehalem EX, you would have 2 CPUs, but then the memory controller would exist in the silicon. And then each CPU, again with a number of cores, would have its own memory address space, which would come out via 4 memory lanes, each with 4 DIMMs on. So that gives a maximum of 16 DIMMs per CPU across 4 memory lanes. And then there would be a similar picture on the on the right side. And then in between the memory controllers, you have a quick path interconnect or a QPI link in between them. So data travels in between the cores via this QPI link. Now, the benchmarks show that the Xeon 7500 and integrating the memory controller gives huge performance increases, and TPCC, VMmark, and other benchmarks will bear that out. But it does bring some problems because what it does is it ties together the way that customers have to buy memory and CPU power. So for example, in a 1 CPU system, if you run out of memory here and your CPUs are running at low utilization, say 5%, then the only way to get extra memory would be to buy the second CPU. So you're getting the extra memory over here, but you're also getting extra cores. With those cores comes extra licensing costs, as well as extra power. Max5, on the other hand, takes the QPI links that are available with the 7500 range, and instead of plugging them into extra CPUs, plugs them into what we call the Firehawk or eX5 chip. The eX5 chip isn't a CPU, so it doesn't draw the same power as a CPU, and it doesn't come with the same licensing costs, which can often dwarf the cost of the hardware itself. And it does give you access to the extra memory which would sit in the Max5 memory drawer. We have blade versions and rack versions of this drawer as well. So in summary, it's changing the way that customers can expand their systems, separating the need to buy extra CPUs just to gain access to extra memory.
So thanks, Jonathan, for that architectural overview of Nehalem-based systems. So early this year, we announced 3 X5 systems, the HX5 blade, 3690 2U system, and the 3850 multi-node system. Now, all of these 3 systems are able to attach to what Jonathan described earlier as expandable memory, or the Max5 system. The Max5 system allows your HX5 blade to have a maximum of 40 DIMM slots. On the 3690, it will give you a total of 64. On the 3850, you have a total of 128 DIMM slots on a single system. Now that increases the memory footprint for a system substantially. We are able to provision extra memory, for example in a virtualization environment where socket licensing costs can incur quite a premium. So in summary, the MAX5 innovation is making customers think about how they want to deploy their systems. Do they invest in CPUs which are relatively expensive, or do they focus on systems which allow them to invest in memory and achieve more and thereby reduce their costs for licensing as well as total cost of ownership?
Thanks to Sonny and John for that brief overview of the eX5 technology and the MAX5 technology. Hopefully you can now see how IBM's creativeness in the x86 market space can drastically reduce cost, specifically in licensing and power consumption within the data center.